This video is going to pick up right where the previous one left. So we are still in the same exercise, okay? We're still pretty much going to modify A01.H, A01.C, but technically this is the next exercise. So the instruction asks us to make things a little bit more dynamical, and there are two different ways we're going to do that, okay? But before we jump into this, let me fix the problem that we still had in the previous version. So at the end of the last video, I forgot to come back and just assumed it was a problem of string length, but you notice that we had, when we entered information here, so let me quick enter some information, 4, 4, 5, 5. Okay, we had this little line break here, and I thought it was just a bunch of space due to the length, maximal length that we're reading, but I looked into it and no, it's a line break. So where is that line break coming from? Well, when we do f get s here, we read actually the backslash n that is typed when I hit the enter key. So we need to get rid of it for aesthetic reason. Okay, we could work with it, but might as well get rid of it. So the idea here is that we want to go to the last index of what we just read. Okay, so easy to figure out. You use strlen. You say data index I dot name. So this is a string I just read. Okay, -1. So I don't want to go on the backslash 0 that represents the end of the string. I want to go on the last character that was actually read. And I want to check real quick if that last character was actually a new line, if it was the character corresponding to the control character corresponding to me hitting the enter key. So data index e dot name. And now I'm going to use that last index that I computed, and I check if it's equal to backslash n. If it's equal to backslash n, then I want to replace it. So I'm going to be lazy. I'm going to say cut and paste off all of this. There we go. This is assigned. And instead of the backslash n, I want to overwrite it with a backslash 0. That means end of strings. Let's save. Let's see if this is working. So compilation error, we're good. Run it. 1, 1, 2, 2, 3, 3, 4, 4, 5, and 5. And this is displaying a lot nicer. And if I ask displaying element number 3 of my array, this is actually employee number 3 with name 4, SSN number 4. Okay. Now that we have this out of the way, let's go back to the main focus of this second exercise, which is I want to make things more dynamical. So we're going to start, there are two things that we're going to make more dynamical. And the first one is going to be this right here. Okay, we don't want to actually have a fixed size array like we had until now. Okay, we want instead to allocate dynamically an array. And since we're going to allocate it dynamically, we could ask, actually I'm going to get rid of this because we're not going to use it. We could ask the user at the beginning of the execution of our program, we could ask the user, how many employee records do you want me to handle? Okay, that's exactly what we're going to do. So printf, we're going to display a little message, a prompt, and we're going to read a number. Okay, how many employee records? And then I'm going to do a scanf. And in that scanf, I'm going to read an int, and I'm going to read it in a variable called, let's call it n. Okay, let's go simple. So I'm going to declare n here. And by default, n is going to be equal to 5. That's what we're using, okay? But we are going to override that immediately by whatever the user enters here, okay? So we are reading this, then we're going to do a get char to get rid of any trailing /n. And now we are ready to allocate dynamically the employee record MyData array. But this time it's not going to be an array of fixed size, so I'm going to get rid of this, okay? And I'm going to say instead, employee record pointer MyData. That's how I declare it, and I'm going to initialize it to null just to be clean. And once I have a pointer, then I can use malloc. So the way I'm going to use malloc is I'm going to say MyData equals. So I want to allocate some memory. Remember, malloc doesn't care really about the structure, it cares about how many bytes you want to allocate. So I want to allocate n times, n is the number of records I want in my array, okay? N times the size of one record. So the size of operator is going to come in handy, and I want the size of an employee record. Please note that instead of employee record here, I could also use struct employee record, okay? These two mean the same thing. They are the same data type pretty much, but we have an alias that's more convenient to use, so let's use it, okay? So this is going to allocate for me a dynamical array. I'm going to convert that address to an employee record star, so the address of an employee record, and I should be all set. And once I have this, then what do I do here? Scan data, my data, and then how many? N. Display data, how many do I need to display? Again, that's going to be N. And then I think that's it, we don't use it anymore. So we have replaced this number of employee record here that we don't need at all, actually. I'm going to remove it. We have replaced with a variable n here that is read dynamically when the program is executing. Well, let's give it a shot. Okay, let's compile to get rid of any, how to say, any compilation error, pretty much, syntax error, or in this case, I'm using malloc, but I didn't include std.h. So let's go ahead and do that. Compile again, compile better. Run it. How many employee records? Oh, let's say only 3. Name is 1, 2, 3. Okay, 1, 2, 3. Which employee do you want to display? Well, let's go with employee, the last one, employee index 2. And there we go. All right. So that was the easy part. Okay, the easy part was, how do I go from using an array, a statically defined array of structure element, to a dynamically allocated array of structure element? Okay. So now that we have seen that, let's go to the second thing that this exercise wants you to turn into dynamical allocation. The second thing we want to turn to the dynamical allocation is right in the middle of this data structure, right here. This string here that has a max length employee name. I want to keep the concept of maximal length for an employee name, but I don't want to have each of my employee record feature an array of characters of that size. Because if I chose here instead of 40, you know, something like 100,000, it's kind of stupid, but whatever number, large number I'm going to use here is going to be allocated for every name field in each employee record. So there's going to be a lot of space wasted pretty much. So instead, what I want to do is I want to read an employee name that is maximum 40 characters, or whatever actually this constant specifies, right? And then I want to allocate dynamically a string large enough to actually accommodate the number of characters that were entered. So it's going to be much less than the maximum most of the time, and allocate it here in the field name so that I can copy the string that was read. We've done that already when we learn to use strings, right? When we learn to use malloc, etc. So it's nothing new, but we are going to adapt it here to this exercise. So what do we have to change? Well, the first thing we have to change here is that we need a pointer. Okay, so instead of char name, max length, etc., I just have a pointer to char named name, and that's it. That's the easy thing. I'm going to keep that because I'm going to use it in a01.c, so might as well define it here in a01.h. So now that I have a pointer, when I'm scanning my data, when I'm getting data from the user, is where I'm going to actually take care of resizing what I read. So here I'm reading directly inside data index I.name. Well, that's not what I want to do anymore. What I want to do is I want to have a char, I'm going to call it buffer, and I'm going to make it an array of, I'm going to go fetch that constant here. There we go. So that's where I'm going to use a constant, okay? I make it an array of max length employee name character. And then I read inside of buffer instead of directly inside my field in the data structure. Once I have read inside of buffer, I'm going to perform the same processing on buffer. I'm going to remove the \n if there is 1 at the end. There we go, buffer, missing all those data, index I dot name by buffer here and here and here. Okay, and this is going to be the SSN. It's not going to change. But once I have done this, read the buffer with fget, then removed the last \n at the end of it if there is one, then what I'm going to do is I'm going to measure the length of what I've read, so the number of actual characters that are there, and I'm going to allocate a buffer, and allocate a string, I should say, for my field, and copy what I had in the buffer inside the string for the field. Okay? So how is that going to work? Well, let's do first int length equal strlen of buffer. There we go. That's going to tell me how many characters actually I use in the name that was entered. And instead of allocating max length employee name, I'm going to just allocate that many characters. So I'm going to use a malloc again. And it's going to be a data index I.name that is equal to malloc size of. And the size of is going to be length. Okay. What else? And that's length plus 1, sorry. Size of length plus 1. And not just length plus 1, size of char times length plus 1. Okay. So how many characters do I want? I want length plus 1 character to account for the \0. Okay, since strlen measures only the number of characters that are in the string, not counting the \0, and I can cast the to char star to be very clean, and that's it. I have my dynamical memory allocation of a buffer of a string, sorry, that is just big enough to contain what I read in the buffer. How do I transfer what I read in the buffer into that new string? strcpy. So strcpy, okay, that's the function from the standard string manipulation library that I want to use. strcpy, and you have to remember it's always the destination and then the source. So data index I.name, this is where I want to copy information, and I want to get that information from buffer. Here we are. Okay, so let's save this, compile it. We're going to take a look to make sure we didn't skip a step here, and then we're going to try it. So how many employee record? Let's go with 3 again. 1, 1, 2, 2, 3, 3, and 1, 2, 3. But this time everything has been allocated dynamically. So what's missing now? I allocated memory. Where did I deallocate it? Never. So that's a problem, right? This is bad programming. This is going to cost you points during exam and as a final exam. So the first thing that I allocated dynamically was my data, the whole array. So that means that when I'm done here in the main, I need to free my data. So that's the first part of cleaning up. Is that enough? No, because inside of my data, every single employee record in there has also a dynamically allocated string. So that means that I need to deallocate them. The moment at which I need to deallocate them is right before my program ends, because I need them up to here to display the information, and only when I'm done doing all of my work on this array, then I'm doing my cleanup phase. Okay, so I'm going to call this cleaning up allocated memory. All right. So yes, I need to get rid of the array, but before I get rid of the whole array, I need to get rid of each element inside that array that I allocated dynamically. So there's going to be a for loop for int I equals 0, I lesser than. So how many elements did we allocate? We allocated n employee record, right? So this is going to be n that goes here. And what I'm doing for each employee record, I'm deallocating whatever I allocated dynamically inside the employee record, which is the string for the name. So my data.name needs to be dynamically deallocated. And therefore, I do all of my cleaning, that's it. And now I have a program that is free of memory leaks. Okay, well, I have a program that is clean in terms of allocation, the allocation of memory. My data undeclared, yeah, that's because I forgot an underscore here. Let's try again. Let's run this again. How many employee record? Let's go with 3. That's enough to make a test. It's not too long to enter. And then which one do you want to display? I want to display the element index 2. And here we are. Okay. So we have pretty much like a, I would consider a final version for this exercise. So it was in 2 parts, right? The first part illustrated just how to get the basic stuff working. This is much more realistic. This is much more in line with what would be expected of you if you are asked to write a similar program during, let's say, an intermediary exam or the final exam for this course, okay? You do not waste memory. You show that you can use dynamic memory allocation and deallocation. So yeah, this is what you need to shoot for, okay? But the first version was an easy way to get into that, and that allowed me to separate in the second video all the aspects that are dynamical. As usual, if you have any question, throw on Piazza, or even better, come to see the TA or myself during office hours. And thank you for your attention. I'll see you in the next video.